Okay, welcome back. So, I promised you before that we were going to talk about catalysts in this next video, and that's what we shall do. So a catalyst, let's just define it really quick before we draw another reaction progress diagram. It's a substance. Notice that I did not use the word chemical. It's a substance that changes the rate. Of a chemical reaction without being changed or used by the reaction. Without being, let's say, changed, consumed. Whoa. This word is consumed. C-O-N-S-U-M-E-D. Since it's obviously quite difficult to see. Significantly by the reaction. So that's what a catalyst is. It changes the rate of the chemical reaction. And we're going to draw a reaction progress diagram to kind of show us what that means. Oh, we love diagrams, don't we? All right. So once again, we've got energy on the y-axis and progress on the x-axis. Ugh. There's a thing in the way that's preventing me from writing appropriately. My mistake. We'll get through it together. So this is energy on the y-axis, reaction progress on the x-axis. We're going to draw a regular old reaction progress diagram. So here we have the reactants, just being reactants, and all of a sudden someone puts some energy in, and then the products are formed. That's the if there was no catalyst present, that's what the reaction progress diagram would normally look like. If a catalyst is present, remember that this space right here is the activation energy. If there was a catalyst present, it would change the activation energy of the reaction. It would require less energy for the reaction to happen. So the dotted line is my activation energy, or E sub A, with catalyst. The regular big line is my activation energy without a catalyst. Whoa, my writing is getting awful. Okay, so on another piece of paper, I'm going to help simplify maybe that definition of what a catalyst is. So let me get that piece of paper ready right now. Okay, so you guys good? Not good? No way to tell. There's no one actually here with me right now. All right. Actually, you know what? Let's talk about what else. Instead, let's talk about what else affects the speed of a reaction. So we talked a little bit about catalysts. I think that was actually an okay explanation of what a catalyst is. Maybe not the best, but I think it was okay. Let's talk about what else changes or affects. Hope I used the right effects. Effect or affect, can never remember. The speed of a chemical reaction. The rate, we'll say, of a chemical reaction. Okay, so that was catalysts. Remember that we said chemical reactions happen because reactants collide together with enough force to make something happen. Okay, so chemical reactions, once again, happen because reactants collide together with enough force to make some reaction happen. What can we do to make them collide maybe more frequently or maybe collide harder? Well, there's a lot of different things we can do. The first thing we can do is we can increase the temperature of the molecules. Okay, not cool. Temperature. That's one thing that hugely affects the reaction rate of any reaction, really. So well, let's talk about temperature just for a second, just in case we kind of forgot, because we talked about that quite a while ago. Temperature is not how hot something is, not really anyway. Temperature is the average measure. So it's the average measure of the kinetic energy or speed. No, come on in, grab the broom.
Yeah, so close the door again.
All right, that's fine as long as there's not much noise back there. Pardon the interruption. Is the average measure of the kinetic energy of whatever molecule you're looking at the temperature of. Of a group of molecules. So I do expect that we kind of know the definition of temperature, not the definition of temperature that you're probably familiar with. That definition of temperature is one that we have got to know because it's actually very important, very relevant, and you know, it's probably quite a bit different than something that you're used to. You know, we're not used to thinking of temperature as being the average kinetic energy of molecules. You know, that doesn't really make a whole lot of sense, intuitively anyway. But really what temperature is, let's draw a molecule of water. So here's some water. If it has low kinetic energy, it's just kind of moving along slowly, being a boring little water molecule. If we give that water molecule a lot of energy, we heat it up a lot, you know, it's going to be flying along at a rocket's pace, and it's going to hit another molecule with a tremendous amount of energy. So much energy that it has plenty of energy to make a chemical reaction happen. It can supply the necessary activation energy for a reaction to happen. So before, in our last reaction progress diagram, which I'm going to put up there right now, that activation energy we said was the minimum amount of energy required for a chemical reaction to happen. It has got to come from somewhere. It could be a spark, or it could just be a bunch of high energy molecules moving really fast and hitting another molecule and causing the reaction to happen. So that happens quite often. I imagine, and I don't know this for certain, so take it with a grain of salt, that the reason the chemical reactions in your body, some of them anyway, slow down when you get hypothermic or when you get hypothermia is because there's not enough activation energy for the reactions to happen. So in your body you have proteins that act as catalysts to digest food or to make any number of the thousands of chemical reactions in your body happen. If the temperature in your body isn't high enough, my bet, and I am not a betting man, but if I were, I would bet the reason that you go hypothermic and then you unfortunately die if you don't fix the hypothermia, the reason that happens is because there's not enough energy to make those reactions happen. There's not enough activation energy. So more temperature, going back to this, more temperature means reactions happen faster. More higher temperature, means reactions happen faster. So this is more / higher temperature. I really apologize about my writing. I'm going to blame it on the pen, even though it's totally my fault. Means reactions happen faster. All right, so that's just that. Now we should probably say why they happen faster, not just be content that they do happen faster. So let's say this is because molecules with higher energy supply more energy to other molecules. Well, actually, I didn't like the way that sounded. This is because molecules moving faster have more energy that they can supply for a chemical reaction to happen. So that's just a little bit about temperature. As you can see, temperature is really quite important in determining whether or not a chemical reaction will go faster or slower. Do I have my next piece of paper ready? Yes, I do. The next thing that we're going to talk about that changes or affects the speed at which a chemical reaction happens is the concentration or molarity of a solution. So concentration and molarity, hugely So concentration and molarity have a huge impact on whether or not a chemical reaction is going to proceed quickly or slowly. And I'm going to draw my imaginary beaker number 1 and imaginary beaker number 2. In beaker number 1, we're going to say there is some molecule floating around. Let's say it's just some molecule that looks like that, and another molecule that looks kind of like that. These molecules, they might be quite reactive, and when they combine, they might be explosive for all we know. But if they never get close enough to each other, they're not going to react. They have got to get close enough. Now, they're in the same beaker. At some point, given a few hours, days, weeks, months, years, they might get close enough to react, but they may not. They may just, be forever alone. If we have another beaker where we have tons and tons and tons of each molecule, okay, they're more densely packed, they're more tightly packed, there are more of these molecules in the same space. There's a higher concentration of the molecules, a higher molarity. There's a much higher probability that they're gonna combine with one another or react with one another. So molarity, just like temperature, very important. Let's just very concisely say that the higher the concentration, the more likely the higher the concentration, the more likely a reaction will happen quickly. Reaction will happen quickly. Okay, so concentration and molarity. Not as much to say as we do about temperature. Still important though, still definitely affect how fast a chemical reaction happens. We have one more thing that's going to affect the reaction rate, and that's going to be pressure. Pressure is hugely, hugely important in determining whether or not a reaction will happen. Pressure is defined very shortly, very succinctly, as the force per area. And if we were to turn that into a nice math equation, it would be force divided by area. Okay, so high pressure reactions are reactions that have a lot of force. So force is like me, throwing my pen or pushing my pen. I push my pen with some force. My reaction, before we start going on the abstract here, let's just define this real quick and say that the higher the pressure, the faster reactions happen, and the opposite is also true. The lower the pressure, the slower reactions happen. So the higher the pressure, the faster a reaction will happen. Okay, this is a definite fact of life, and it's because in areas of high, well, let's not be general, let's be very specific. This is because higher pressure forces molecules together. So if molecules are being forced together by something, they're being given some energy, perhaps enough activation energy to make the reaction happen. They're being forced together, meaning that they will come in contact. They'll come in contact enough, probably, to cause a reaction to happen. Pressure is really quite important in whether or not a reaction will happen. Okay, so if you guys have this is really all that I have for figuring out how fast a reaction will happen. We talked about, let's see, what did we talk about today? We talked just a little about why reactions happen. We talked about pressure, concentration, and temperature, all affecting the rates of reaction. We talked a little about catalysts and how they affect the activation energy and the rate of a reaction. All right, so that is that. I hope you guys found this somewhat helpful. If you guys did, please let me know if you guys have any feedback for the future. I think in the future I'd want to have demonstrations here on the video, but I'll have to be a little bit more forward thinking about that, I think. Thank you guys very much and have a fantastic day.